We are going over test number for chapter number 13. Number 1, you were to define calorie, and you should have said something about the amount of heat needed to raise 1 gram of water 1 degree Celsius. Then specific heat capacity was the amount of heat to raise a specific mass, or you could have said 1 gram, and I would have taken it because that's a specific mass of substance 1 degree Celsius, but it took into account the mass is the point. Latent heat is the amount of heat absorbed or released to have a phase change. Okay, exothermic reaction releases energy, and potential energy is stored energy. Okay, number 2, if the energy in a serving of food can heat 450,000 grams of water 1 degree Celsius, how many calories are in the serving? Well, if it takes 1 gram of water 1 degree Celsius, but calories here are with a big C, so it's 1,000 calories. So we have, it takes 1,000 grams of water to raise it 1 degree Celsius. That means 450 calories actually is 450,000 little c calories, and therefore it would take 450,000 grams of water to raise it 1 degree Celsius. All right, number 3. The question is, heat is added to a substance, but its temperature does not change. What is happening to the substance? It's undergoing a phase change. Has to be, doesn't it? Number 4, we have 2 objects. The same amount of heat is added to each object. Object A reaches a higher temperature than object B. No phase change occurs. Which sample is made of the substance with a higher specific heat? That would be B. Okay, number 5. For the following units indicate whether they measure heat, specific heat, heat capacity, or latent heat. And so heat would be calories, specific heat capacity would be, let's see, A is latent heat, B is heat. I'll do it their way. C is specific heat capacity, and D is heat capacity. Okay, because notice C has a mass involved with the grams. That's why it would be specific heat capacity. Okay. Okay, number 6. How much energy does it take to heat 2 kilograms of water from 25 degrees to 75 degrees? And so here we're doing Q equals MC delta T, and we are looking for the energy. So the mass of the water is in grams, 2.0 times 10 to the third grams times 4.184 joules grams degrees Celsius. And the change in temperature that we have is 50 degrees Celsius. Yes, so it's 50 degrees Celsius. And so you would answer in 2 significant figures because this limits you to 2 significant figures. And so your answer is 420,000 joules. Okay, number 7. The answer is 994 degrees Celsius, 994 degrees Celsius. Any questions there?
I didn't see that.
You didn't do 7? Oh, you need to see 7. Okay, okay. 7. 50-gram sample of tungsten loses that much energy and ends up with a temperature of that. What is its initial temperature? So we have Q equals MC delta T. We are told that it loses, so that's this, negative 5, 6, 8, 7 joules equals, the mass is 50 grams. We're given C as 0.134 joules per grams degrees Celsius. And delta T we know is the final temperature minus the initial temperature, which here we're given that it ends up at 145 degrees. So I'm going to come in here and put, be nice, 145.0 degrees Celsius minus what we're looking for, which is the initial temperature. Correct? Did you have that all? No?
Yeah, that's why I asked to see.
Okay, then I'm not going to show you anything else.
Okay.
So that you can go home and do that. Okay?
Okay.
But you see, you're just plugging in for this.
Okay.
All right? And then you just literally plug in. Yes, ma'am.
What if I did that and I feel like I don't know, like I just, because I actually did the whole solving for delta T and did the Q over MC, plugged it all in.
Okay, well, let's do it. If you did all that and you still had a problem. So we need this. So the first thing we're going to do is we're going to take this and divide by these two. And so I'm going to take this and I'm going to get these two guys over here. So I'm going to divide by the 50 grams and by the 0.134 joules per grams degrees Celsius. Okay, let's do that first. So we have 5, 6, 8, 7 negative divided by 50 divided by 0.134 equals. That gives me negative, 3 significant figures, 849 joules cancels, grams cancels, that gives me degrees Celsius. Does everybody see that? Okay, so far. And what I got in my calculator was 848.80 blah, blah, blah. But I've got 3 significant figures here, so I'm going to make it in 3 significant figures. Okay, equals, and that's 145.0 degrees Celsius minus Ti. Now, I'm going to go ahead and add this to this side and add this to this side. Okay, I just don't like negatives. So I'm going to add this to this side, so that gives me equals, well, and if you want to see it, I'll just leave it there for a minute to show you. Okay? Now I'm going to add this to both sides, so I can get this guy by himself, just good old-fashioned algebra, right? So it's going to be 145 plus 849 equals, and we go to the ones place because this goes to the tenths place, but this only goes to the ones place. So what comes up in the calculator is 994 degrees Celsius.
I got that doing it this time, but like I don't know, I guess.
Okay, but you have everything written
I
there?
had everything down the same exact way and I got like a different number.
Okay,
So,
you
but
probably
but
just
I just did it right now and
push,
got it.
okay, but you have everything written down, so just leave it, that's good, okay. All right, Andrew, you see how you do those?
Yeah. The only thing I didn't have was when I did the original was the 45. What is that?
145?
Yeah, I didn't have that.
That's the final temperature.
On my answer, I put what I put as my answer was the negative 8 or negative 840.
So you just didn't finish it.
Yeah.
You need to finish it,
Okay.
okay?
All right.
Okay,
I'm so confused.
let's see, that was number 7. To describe a calorimeter, you could have even drawn a picture and labeled it, but basically you have something. Did you do that? I would have too. I'd have drawn a picture. Basically you have something that you, like a styrofoam cup, that it doesn't let the, it's insulated. That's the word I'm looking for, something that's insulated, and then you have a thermometer in the top, and you have something to stir it inside, something like that. You could have drawn it, it would have been fine. All right, number 9. 125 gram sample of metal is heated to 100 degrees and placed in a calorimeter that contains 250 grams of water. The temperature rises that. What is the specific heat of the metal? Ignore the calorimeter. And so we have negative Q of the object equals the Q of the liquid. We're ignoring the calorimeter. So it's negative MC delta T of the object equals MC delta T of the liquid. Let's see. We have negative 125.0 gram sample of the metal. We are looking for the specific heat of the metal. And now the temperature change of the metal, we're told that the metal is heated to 100 degrees Celsius, and the final temperature of the whole thing is 27.2 degrees Celsius. So that gives us a temperature change of excuse me. I need the metal. There we go. Of negative 72.18 degrees Celsius. So I'm going to put that in here, negative 72.8. Don't listen to what I'm saying. Degrees Celsius. Okay, we've got that. All right, now equals, and then we are given 250 grams of water. You memorized 4.184 joules, grams, degrees Celsius. And the change in temperature for the water is, the final temperature is 27.2 degrees Celsius minus the initial is 24.3 degrees Celsius. And so that gives you a change in temperature of 2.9 degrees Celsius. I'll put that in here. Okay, and then if you solve for C with two significant figures, your answer should be 0.33 joules, grams, degrees Celsius. And if you have all that there and you didn't get that answer, go back and plug it in your calculator again because you've done something wrong. And in college, you won't be able to do that. So make sure that you do this over and over again to try to make sure you have the correct answer before you walk away from it. Okay, let's see. That was number 9. Let's do number 10. A 750 gram sample of metal is heated to 100 degrees. It's placed in a calorimeter, contains 1,000 grams of water. The temperature starts out at that, ends at that. Calorimeter has a specific heat capacity of that. What is the specific heat of the metal? Well, in this case, we have negative Q of the object equals Q of the liquid plus Q of the calorimeter. And remember, this is negative MC delta T of the object. This is MC delta T of the liquid. And this is, well, I'm just going to go ahead and put it MC delta T of the calorimeter. Okay. So let's start plugging in. And what we're looking for on number 10 is the specific heat of the metal. And that's what we were looking for in the last one, too. Okay, so the metal is 750 grams. We're looking for C, so I'm just going to leave C here. The change in temperature of the metal, it starts at 100 degrees Celsius, and it ends at 26.5 degrees Celsius, because remember, everything ends at the same temperature. 26.5 minus 100. And that gives me negative 0.5 degrees Celsius. So that's the change in temperature for the metal. So I'm going to put that in. Number 10. Good. Okay. Now we go to the liquid. The liquid on number 10, we are given 1,000 grams of water, 4.184 joules, grams, degrees Celsius. The change in temperature on the water, final temperature is the same for both, but it started at 24.9 degrees Celsius. And so its change in temperature there it is, 1.6 degrees Celsius. So 1.6 degrees Celsius, and then we are given the heat capacity, which is the mass times C, the specific heat, and for the calorimeter. So that is 1,101 joules per degree Celsius. And then the temperature is the same as the liquid. Okay. That is your setup, and you're solving for C. You need an answer in 2 significant figures. And so your answer for that one should be 0.15 joules, grams, degrees Celsius. Make sure you have all that, and that it should be in 2 significant figures. Number 11. If you have 500 grams of water at 50 degrees, how much energy would it take to turn it all into water vapor? Okay, so it's already water. And remember, Q equals M and then L, depending. And this one, we're going to vaporize it, so it's going to be LV. Okay, now, the water's already at 50 degrees, so we know it's definitely in the liquid phase. So first we're going to do the Q to get the water from 50 degrees to 100 degrees where it'll vaporize. So Q equals MC delta T. And so the mass of the water is 500 grams. We have memorized 4.184 joules, grams, degrees Celsius. And the change in temperature, the final temperature we're going for is 100 degrees. And we started at 50 degrees. So it's going to be 50 degrees Celsius. Okay, so that's the first step. And when you do that in 3 significant figures, yeah, you get 105,000 joules. Okay, that gets us up to 100 degrees. Now we have to vaporize it, so we're going here. We have our 500 grams of water, and he gives us LV at 2,260 joules per gram. And so that is going to give us, in 4 significant figures, 1,130,000 joules. Now we have to add these 2 numbers up. I'm going to do it here. Okay, but the significant figures have to go to here. That's the least precise, so it has to go to here. So your answer should be 1,240,000 joules. You could have rewritten this. There. So you could have answered that either way. But it had to be in 3 significant figures because of the least precise. And you're adding or subtracting. Number 12 is exothermic, and number 13 is potential energy. And we'll have to go by the way he's done it. So if you have questions, look at how he's done it and take off point-wise how he's done it, okay? Because I don't even want to start trying to figure it out. I would say make everything 3 points apiece, but then what he's got, 11 would be worth 9 points. 10 would be worth 12 points. You see what I'm saying? So you probably want to go ahead and try to get as many points as you can.